Hello, today in this video I will show you how to do a point force and a line force analysis on this beam. Point force will be acting on this point and the line force will be acting on the entire beam. So let's start. So I will open a new file. So now I will show you how to make this thing happen. I'll keep this aside and keep this here so you can see everything correctly. Okay, so the first thing you have to do here is create a point slider. So yeah, I will go with the value 10 and I'll create 2 points. For that I'll go to the construct point. In total I want to create 4 points for my beam, so I'll copy this 4 times. Okay, so I copied it 4 times. So the first point I'm going to create is 10. So I created a point 10. Next point I want to make is minus 10. So I put this value here, minus 10. Okay, so the next point I want is 0, which is this point. And the third point I want is 20. For that I create a multiplication factor and connect the value 10. As you can see, this value is empty, so I have to create a 2 for it. Connect it. I created new point here. So in total I have 1, 2, 3, 4 points. Now what I want to do, okay, so the start point is this one and the end point is this one. So I created a line from here to here. Now the second line what I want to create is from here to here. So I create another line. I want to create one more line, so I'll copy this and keep it here. Start point is this one and the end point is this one. So I created this line and this line. Now I want to create a line here. So I connect. This will be the end point. This will be the start point. So I have created 3 lines for my beam. So I have created 4 points and 3 lines for making the beam structure. But now what I'm going to do is split this curve into 2. For that I will use a command called Shatter, which basically trims the line. and I need a parameter. For that I will choose closest point on the curve. So this is the curve which I want to select, and the point, I will create the point on curve from this command. So now I select the curve and I give the point to the curve closest point. So basically I have created a point in between of the curve, and now to shatter or trim this curve at this point, I'll connect this parameter to the shatter. So now you can see two locally defined values, line like curve, are created. Now the next thing is I want to merge all the data of these 4 lines. For that I have to create a merge command. So I have total 3 datas. I will select line 2 and 3, and yeah, now the 4th line is a mixture of 2 lines in the shatter command. So I will use a command called as shift paths. Shift paths. So now what I do is I take this data and add it to the data collection. Now after this I want to create a beam. So I use a line to beam command, which is in the Karamba. So I select this result and connect it to the line. For the identifiers, I'm going to create a panel where I will type in multiple line data beam 1, beam 2, beam 3, beam 4. So I create 4 beams in my panel for identifying each curve. Now the next thing I will be creating is an assembly. So I want to assemble all this model. So these elements are connected to this assembly. So when you connect this line to beam data to the assembly model, these data are in multiple forms. So you need to flatten this up so that you get single values, and then Then you need to create a support on which you want to analyze this particular beam. So creating a support, for that you need to create a support command. So support Karamba 3D, this one. And now you have to create supports from this point. I create a support on this point. This is the center point. This one. I want to just make this support move on Z direction only. So I lock all the other parameters. So I want this particular point to move only in Z direction, and the support will only help the beam to move on the Z direction. The next support which I'm going to create is similar like this, but on different point. So I select this point and this point for the support. So I give two supports at these 2 points. Okay, so you have to shift and add this 2 here. So I created 2 supports. I want these supports to be rigid and I don't want to move it on any direction. So what I'm trying to do is I'm trying to make this beam fix at these points, and this support is not going to move in any direction or is not going to rotate at any direction. Same goes for this. So only this part will act as a beam. So only this part will act as a beam which will bend on the Z direction. So now I add both of the support to the assembly. I have to flatten the data for this as well. So now I'm done with the supports. So I created a line to beam, I created the support for the beam, and now what I need to create is the load. So for creating load, I need to first define the type of load I want and on which point. So I create a load. So the type of load is a point load, and the force is going to be connected to maybe this value. So for that value I need to make So I want to make it on the negative direction. The force should be going in the negative direction, so I have to create a negative factor. I need to create a unit Z. So this factor will be connected to this and the force will be negative, so I'll connect it to the force. Now what I want to make here is a multiplication factor. So I create a multiplication factor, so I multiply this value of 10 and I will multiply another value as well, but right now, yeah, I have created this. So this will act as a point load. I want to create a uniform line load as well, so I create uniform line load. So this will be in the middle, so I have to create the same. I need to create everything like this. Just disconnect this and connect this vector here, but now I want the value of force to be different, so I'll connect this value of the force, that is 0.5, and the same multiplication factor, and the same value will be connected to this multiplication factor, so I control the value of force for this point as well, so it will be multiplied by 5 because here it is 10 and here is 0.5, which when you multiply is 5, and the value for this force will be 5. And it is a negative, so this will be -5. So now I created a uniform line load and a point load. So I will be connecting this to the loads. Okay, so I need to connect it using the shift button. Okay, so I connected both the loads. Here I can see some error. So this error is input parameter position is failed. So I need to give a position ID for this point load. So yeah, I know the position is this one, so I need to find this point on my grasshopper. I guess this is the point. Yeah, so this is the point. I connect this point to this position, so now everything is fine. And yeah, I flatten this, so the assembly model you can see here is having two different forces, uniform line and the point force. So as you can see here, the assembly has two forces, that is uniform line and the point force. Now the other thing what I have to do is the same position which I gave for this point load, I have to define for this uniform load, but this takes in terms of beam IDs. So I have created the beam ID here, beam 2 3. So I need to copy, or I need to create a new panel on which I enter beam 2 and beam 3. So I want it in multiple line data, so I connect this to the beam ID. So now the load will act on these two beams. So after making the model, you need to analyze. So I select this, I connect the model to the Karamba 3D, analyze function, and then I want a model view. I want to view this entire model. So what now we have done is we created a beam on which we created supports and loads acting on this beam. So we finally assembled all this together and then made the Karamba 3D to analyze it. So now we have the analyzed data here. So the next thing I will make is model view so that we can view this model. So I connect this here and you can see, okay, so the problem here is this uniform force is acting on this beam, which is wrong. So I need to change this condition. So I need to change maybe to beam 1 and beam 2. Okay, so now this is correct. So when I change the beam ID, you can see the uniform line force acts on different beam. So the next thing you need to do is create colors. So for that you need a gradient. So now I select gradient for the color. So now I create a range, connect it to the parameter, and the domain will be 0 to 1 and the steps will be 10, which I don't care now about because I just need to make this gradient. So to change the type of the gradient, I need to preset it I want to make it look like this, and now I have this gradient pattern, so the value keeps on changing as per this gradient, and it will show the respective color on the beam. So now I connect this gradient to the model view, and I need to make a beam view. So now I will make a beam view, so that we can see how the beam looks like. I connect this model. So to see how the beam looks like, I need to also click on the displacement settings. So now I can see, yeah, this is the displacement happening on my beam. So there are multiple settings here where you can have different view for the actual stress or for the displacement or for the utilization. So you have different values here. So as you can see here, this blue part shows this is the point where we have the highest value as per the gradient. So now the next thing you need to do is, so now the next thing what you can do here is check your beam forces value. So for that I put this analyzed model into the beam forces, and I select the beam identifier. So I connect my panel to the beam identifier, and I type beam 1 and beam 2. So I want this in multi-line data. After this, I have data of the normal forces acting on the beam, shear force acting on the beam. The data of the shear force, so I connect the shear force to the panel, so I know these are the values for the shear forces. And now I want to know the highest and the lowest value for the shear force. So I create a bound. So bound gives you the minimum and the maximum values for that particular data, and I connect this to a deconstruct domain. So now this will start from the minimum to maximum, and I can see these value on my panel. So this is the minimum value and this is the maximum value acting on the beam. So in this way you can calculate the shear forces on this bound or on this domain, and you can get the values. The same you can do for the bending moment along the z direction, or along the y direction, and as the beam is going in the vertical direction, and I'll create a copy for this. So I disconnect this one and I connect the moment along Y, so you can see the moment is 10.4166, which is the highest on this beam. So when I put these two particular forces, these are the values. If I turn off the uniform line, the values will change. You can see here it's 6.25, which was not the value earlier, but when I add this, so it gives a combined value that is 10.4166 for both these forces acting on this beam. So I hope you guys understood how to do a analysis on a beam by using Karamba and the different functions on it, and get the data of the shear force and the moments acting on the beam.